Multihop amplified relaying optical network to improve transmission signal quality. Abstract optical amplify-and-forward (OF) relaying technique can amplify and filter the attenuated optical signal in optical domain, and thus is regarded as a simple way to extend the transmission distance of free space optical (FSO) communication systems. The data transmitted over the optical wireless communication channel may fade due to turbulence effect, scintillation effects etc. In long-distance communication, the transmitted data is affected by inter-symbol interference. The ISI is removed by introducing the relaying network with duobinary scheme. The relay network with proposed hybrid amplifier and duobinary signaling scheme reduces bit error rate and improves quality factor. Keywords: gain flatness, multi-pump, hybrid structure, high gain low noise figure. Duobinary signaling, relay, multihop. 1. Introduction. To lengthen the transmission distance of free space optical communication and also to resolve the optical signal impairments, multihop relay network with duobinary correlative signaling is adopted. The relay network performs amplify and forward, and the amplification when performed in better way reliability is ensured, and to increase the transmission capacity of network duobinary signaling scheme is done, and this additionally provide ISI reduction as ISI is intentionally added at the transmitter side. The relay node is optical amplifier, and when it is necessary to flatten the gain of the amplifier used, and so hybrid amplifier in cascade structure is adopted. 2. Multihop relayed optical network. In optical communication network, to improve the transmission distance over wider distance, multihop relayed network is used, and also when we go for free space communication the environment is more pollutant, and so signal contamination is higher due to environmental factors, and so over information carry the signal has to be amplified and forwarded, and for amplification a better relay element has to be used, and the relay is also an important element to be designed efficiently, and so a cascaded hybrid amplifier structure is used to clean up the contaminated signal in digital communication over fiber. K. Sindhuja, AP, Department of Electronics and Communication. Thini Kamavar Sangam College of Technology. Thini. Fig. 1. Multihop relayed network. 3. Duobinary signaling. Intentionally adding ISI at transmitter side to double the transmission capacity, and this also mitigates the effects of ISI. The ISI is added in controlled amount by increasing the correlation between the adjacent data, and so this signaling is said to be correlative coding. As transmission channel is dispersive in nature cause severe ISI, and this is resolved out as already the ISI is introduced. Fig. 2. Duobinary signaling at transmitter side. The precoder preceding the duobinary coder avoid error propagation and buffer requirement. 4. Duobinary signaling in multihop relayed optical network. The digital data is first waveform encoded with duobinary correlative coding to increase transmission capacity and to improve reliability. The waveform encoded baseband transmission is converted into passband data by MSK modulation technique and sent through the free space channel. The multihop relayed network ensures reliability as it cleans up the repaired signal by amplify-and-forward technique. This multiple advantageous technique make the network yield low bit error rate and high Q factor. Q factor IJERT 11 is 010085 www.ijert.org. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by International Journal of Engineering Research and Technology, IJERT. www.ijert.org. ISSN 2278-0181. Volume 11 Issue 01, January 2022. Measures the quality of the signal and which is the main figure of merit for analysis the network performance. 5. Simulation results. The single-hop network with optical free space communication is simulated initially with PSK and MSK modulation technique, and performance parameters are analyzed. Results shows MSK modulation technique performs better, and so multi-hop optical relayed network and multi-hop optical relayed network with duobinary signaling with MSK modulation is simulated and performance parameters are analyzed and compared. Table 1. Comparison table. Modulation techniques by terror rate, Q factor. PSK 0.0208391.2.03629. MSK 0.001396.3.60105. MSK Dual Hop Relay 1.36014E05515.6625. MSK Dual Hop Relay with Duobinary Signaling 1.04139E21030.9561. The relay used is amplifier element, and so it is necessary to meet the demand by proper designing of relay element. The relay element should be with high gain and low noise. The relay element proposed for this multi-hop relayed optical network is the hybrid amplifier cascaded structure. 6. Optical amplification. Optical amplification increased S's gain and also increased S's the range of operating frequency. Different types of optical amplification is available using different techniques. Optical pumping introduces amplification. Fiber amplifiers are available, which makes implementation easy with much efficiency. To have high flattened gain, diversified techniques are available. The conventional available Raman and EDFA amplifiers offers amplification gain to an accountable extent. When these conventional amplifiers when come in cascade offers high flattened gain. 8. Hybrid amplifier. Hybrid amplification is the best method to increase gain and to achieve low noise figure. In WDM network covering long distance undergoes various attenuation and so signal becomes weak. To boost the information signal, EDFA amplifier is used. The pump given to EDFA transfers energy to information signal and dies. To flatten the gain of EDFA amplifier, Raman amplifier is cascaded. EDFA Raman configuration performs well than Raman EDFA configuration. Raman with multi-pump performs well than Raman with single pump. EDFA amplifier is fed with forward pumping and Raman is fed with backward pumping. The virtual implementation is made in Opti System 0.7 and the schematic is shown below. Fig. 0.5 Schematic diagram of diversified amplifier. Table 2. Simulation parameters. WDM transmitter, EDFA amplifier, Raman amplifier. Frequency equals 1552.52 nm, length equals 13.5 m, length equals 10 km. Frequency spacing equals 2 nm, core radius equals 2.2 ER doping multi-pump, frequency equals 1462 nm. Power equals 26 dBm, radius equals 2.2 frequency equals 1467 nm. Modulation type equals NRZ-ER, ion density equals 1 E equals 0.25 m, frequency equals 1452 nm, frequency equals 1457 nm. 3. Power equals 500. Numerical aperture equals 0.24, power equals 500, power equals 500. Single pump, frequency equals 1490, power equals 500. Power equals 100 MW. 9. Simulation results. The comparison were made for many configurations of hybrid configuration, and the configuration of EDFA Raman performs well with gain around 52 dB, increased gain, flateness and noise figure of about 4 dB. This shows the optical signal has to be EDFA amplified first and then it has to be Raman amplified. The figure above represents the comparison values of various amplification configuration, and the results shows the EDFA Raman hybrid amplification gives optimum gain, flateness and increased gain of about 52 dB. Fig. 0.7 Wavelength and noise comparison chart. The figure above represents the comparison values of various amplification configuration, and the results shows the EDFA Raman hybrid amplification gives reduced noise figure of 4 dB. EDFA Raman with multi-pump outperforms well with gain around 50 to 60 dB and noise figure around 4 dB. Hybrid amplification with better amplifier arrangements improves WDM network performance. This cascaded amplifier structure works best as relay element in multi-hop optical relayed network. 10. Conclusion. The data transmitted over the optical wireless communication channel may fade due to turbulence effect, scintillation effects etc. To repair the contaminated signal over this noisy environment and to transmit over longer distance, multi-hop relayed network architecture is used, and this provides better performance criteria. In long distance communication, the transmitted data is affected by intersymbol interference due to the dispersive nature of the transmission channel. The ISI is removed by duobinary scheme. This relayed multi-hop network incorporated with duobinary signaling scheme further improves the performance. The relay element in network, when replaced with this hybrid cascaded amplifier structure, the results are more pronounced by achieving the desired performance criterias.